The rest, I'm sure, will get the video shortly. Today is our first day of our Calc 1. I mean, kind of important, you know, calculus is a very, very important branch of mathematics, probably the most important branch that most of you will ever deal with. There are a lot of calculus classes, not all of them you'll end up doing. It really depends on your major. If you're an engineer, you'll probably do every math class under the sun, trust me. Certain branches of engineering will do more and some will do less. So if you're an electrical engineer major, you probably won't need to do more than Calc 1 and 2. And if you're going to be I'm going to call them industrial, that's not what I really mean. You know, if you build bridges, you'll probably do every calc class in the universe. So what are we going to be doing today? Well, I've got a list because I'm very forgetful. And I'll show you that list right now. It's here. And essentially what we're going to be doing is going over the syllabus first, which is not a surprise for the first day. And after that, we'll get started. And our first section is 2.1, chapter 2, section 1. And we'll deal with what's called the tangent line problem. Here's a little list of things that we're going to do. Everything that you see on video gets put on Canvas. So you don't need to frantically write down this list unless you feel you want to. It will be there. You can go back and look at it in the future. That's also going to be true about the syllabus, because I'm going to be hitting you with an awful lot of information at once. And unless you've really got a great brain and can memorize everything, you're going to forget some of the stuff that I say. So you'll just go back and look at this video and say, oh yeah, I remember now what he was talking about. So that's kind of where we're going to do. We're going to do syllabus, and then we're going to start on the tangent line problem. And we're going to do things, for instance, like find the slope of a line, just to get used to it, find the slope of what's called a secant line, use that to estimate the slopes of tangent lines, and then go into more detail in calculating these tangent line slopes. So let's do the syllabus. Right, you should be looking at, I hope, our Canvas site. If I see some nods, I'm good to go. Is that what you're saying? Right. Okay, so this is where you go. The class is really broken into two separate chunks. Canvas is one chunk and WebAssign is your other chunk. In WebAssign, that's where you're going to do all your homework, a lot of your all your online tests and stuff like that. So that's where you do your work, your day-to-day work, right, homework and so on. And then Canvas, what we're looking at right now, it's where you get pulled things. That's where all the information is. So in this case, if we click on that top one, hopefully Canvas will behave itself and not do anything weird. Takes a little time. There we go. What you're looking at here, if you haven't already looked over, basically gives you the information about the technology that you need. For instance, I really do need to, and I'm pushing it this quarter, I do need to see you. It just makes my job easier. And if my job's easier, hopefully I can benefit. So when I look at your faces when we're doing some stuff, I get a lot of feedback about how well I'm explaining something, or whether I need to slow down or maybe do it differently. Plus, if it's easier if I get used to you visually. I think it helps communication. So what this tells you is that you don't really need to get a physical textbook. What we use is WebAssign, and WebAssign has an ebook, basically an electronic PDF version of your textbook. And here it tells you how to enroll in WebAssign, and you just go through these instructions. And I'm not going to do that because I know you all can read. And that's what that one's all about. Now, once you're in WebAssign, you've got, I think it's 14 free days. So it gives you enough time for your financial aid to come through or to decide if Calc 1's really for you, in which case if you drop it, you haven't forked out any money, right, to buy WebAssign because you haven't bought it yet. Here you'll find after that then is our Zoom link, which will be this one that you got to the class today. And I think that lasts for about 6 weeks and then I have to change it. That's this one here actually. Yeah. And this one here is our officer. Now our officer is directly after this class. So if you really need to see me about things, which I'm assuming will happen, right after this class works, right? So just basically we'll leave and we'll appear in a different Zoom room. And these are the kinds of things that you can get in Canvas. So let me hopefully go back. So if you click on that, it'll tell you some information about me. Jason, do I have an accent?
Of course not. It's all of us that have the accent.
Correct. You all got that? So if some of you are freaking out when you first heard me, trust me, I think after a couple of days, nobody even bothers. It's just the funny way I talk, right? It'll not even be noticeable. Would that be a fair description? A couple of days later, you don't know. It's nothing different. Jason, would you say that? You can say no, it's always weird. It's also true.
Sorry, what did you say?
I was just saying, after a couple of days, you don't really notice. It's just a funny way I talk.
Oh, yeah.
Yeah. So most of the words are the same. And most people can figure out by context if I say a strange word. What else about me? Well, I'm getting old. I think that's pretty obvious. I'm getting older. I started getting paid for teaching in August of 1980, which is probably older than some of your parents. That's how much I've been teaching. So I've been doing it for a long time, still don't know what I'm doing, but I keep trying. And what other things? I come from Scotland, come from a place called Belsill, which is roughly about halfway between Glasgow, which is the biggest city in Scotland, and Edinburgh, which is the capital city of Scotland. And it's a place in Scotland called the Central Valley, which is pretty much the flattest part of Scotland. Scotland's got a Central Valley. To the south, we've got hills called the Southern Uplands. And to the north, we've got the Highlands. So I live in that valley in the middle. What else? I'm one of 10 children. I'm number 8 in the list. Only one in my family went to university. None of my brothers or sisters. None of my cousins. None of them went to university. So I'm a bit of a weird rarity. But the next generation, i.e. my sisters and brothers' children, an awful lot of them have went to university. So I was a kind of the role model, I guess. They figured out if Uncle Donald could get through university, anybody could. So they all decided to do it. And that's a little bit about me. Right, the next one, this is where there won't be any because we haven't done a video, but if you click on this and you go to week 1 and you click on that, in this box to the left will be this video and tomorrow's video and Friday's video. So that's where you'll find them. If you click on this one, it's just a link to our officer at 9 o'clock. If you have problems with Zoom, WebAssign, here are some links with information to help you. Don't need to worry yet about Microsoft Lens. That's really a piece of software that you're going to be using when you upload your working and things like your midterm and your final. Then if I click on this one, because I have a weird sense of humor, there's some really cool, I think, videos and cartoons and things. Just a bit of fun. Now, if we click on, let's close this one off. If we click on this module, it has other videos, not mine, but other people's videos, ones that I've found on YouTube, and for instance. And for instance, here is 10.1. And if you click on that, there's a couple of videos by other people. And the reason I put things like that there is that not everybody learns the same way. I'm sure the way I describe things isn't always as clear as it could be. And we've hit our first technical problem, which is it won't let me go out. There we go. So I put them there so that you can see someone else's way of looking at things, right? Someone else's way of describing it or explaining it. Plus, very often there's other examples where people have done questions and showed you how they got the solution. So it's just a resource, and you can choose to use it or not. This section has some homework help. Chapter 3, some homework help. Chapter 4. And this little guy here called Desmos, if I click on that, this is a cool resource that allows you to essentially there we go. Allows you to sketch things. It's really cool, really colorful. Kind of better than your TI-84. You know, your TI-84 is a tiny little greyish screen. Isn't that just cooler? Just nicer. So, if sometimes you want to visualize something, and that's a good way to do it. So, that's some new resources. Here we have college resources, which tells you all about, you know, things the college can do for you. And let's look at the syllabus now. Can I make that a little bit bigger, I think? I'll try. There we go. So you want to communicate with me. Email's the best. There's my email. You can do it either through drobertson@olympic.com, or you can do it just inside Canvas. You know, there's a feature in Canvas where you can email me. Do not, I'll kind of repeat that again, do not use any of the links in WebAssign. WebAssign has buttons like Ask My Professor or Ask for Help or something. It's a pain in the butt for me to get that. It isn't directly linked. And unless I go physically in and look for someone asking a question, I won't even know. So if you want me to answer you, email me, right? Either directly or use Canvas. And that's the only way I would ask you to communicate so that you can get an answer. So we're Calc 1. Calc 1 deals with calculus. Here's a repeat of the stuff that you need. If you don't have some features, you can go and get loaners off the IT people at Olympic College. You do not need a textbook. This is the code in WebAssign for our class. So if you have already joined, which you really should by the end of today, that's the code that you'll use. And I have instructions for it. So if you go and look in Canvas, I take you through step by step how to do it. So it is there. Here are the key dates. Let's talk about holidays first. I believe there's a holiday on Friday the 13th. It's probably a good day to have off if you're superstitious. And Monday the 30th is Memorial Day. So there's our two holidays. As far as big exams go, there are only two biggies. Your midterm is going to be on Monday the 9th. Well, that's the right date. And your final is going to be Wednesday the 15th. And we'll talk a lot more about them nearer the time. Now, what you're looking at here is the 11 weeks that this course is going to be. And here are the two sections that we're going to cover and give homework this week. 2.1, tangent line, and 2.2 limits. And there's a test. And that all three of those things are in WebAssign. The homework is flexible. You do half an hour, you come back in, you go back 2 days later and finish it off, don't matter. The online test has a clock associated to it. You've got to do it by the end of Sunday. as you have for all homework assignments. But if you decide on Saturday at 2 p.m. that you're going to do the test, the minute you click on that test, a clock starts ticking and you've got to get it finished in one go, right? So make sure that when you do a test, you're actually ready to do the test, right? And the test is always only going to be on 1 week's work. So in this case, it's going to be on these 2 topics here. And then week 2, it's going to be in these 3 topics. And week 10, it's going to be in those 2 topics. And it should be here. There's our midterm exam. And there's our final. And the midterm exam is going to be on the first 5 weeks. And the final is going to cover all 10 weeks. Whew, that's a lot of info, isn't it? Any questions? Kind of know what's going on? I know it's a lot, but you know what's happening. Yeah. So that's kind of the day-to-day, week-by-week run. I said there's 11 weeks. Technically there is, but week 11 is exam week. So it's a bit different. Monday is a review for the final. So you turn up on that day if you have any help, any questions you need help on. And then I don't see you at all until the final. In your case, it's on Wednesday. Notice that it starts at 7 rather than usually. That's the only thing there. Well, what's next in the syllabus? This is what you're going to learn, hopefully. Calc 1 deals with what are called derivatives. How to calculate them, how to use them. That's basically it. How do you find these things called derivatives, and what do you do with them? Obviously, there'll be a lot more detail to that, but that's essentially it. Don't cheat. If you have need of extra accommodations, you can just wait behind at the end of the day and we can talk about them. It simply could be that some of you need extra time to do those tests, and that's easy, I can fix it. So let's talk about how you get your grade. It's made up of 5 things. The first one is participation. That's going to be 10% of your grade. Homework is 20. There are 10 online tests, right? 1 for each week, 20%. There's a midterm worth 20. And there's a final exam worth 30. So that's where all the points that will make up your grade comes from and the weighting of them. So here goes for participation grade. There's basically going to be, oh, interesting typo. Never mind. They're going to be participation points for coming to class. Actually, that number there should be 50 because it's 10 weeks times 5 days. So that's 50 points. It's going to be turned into percentage anyway. And on top of that, you will receive 1 more participation point every week, 1 a week, if you don't ask for an extension to the homework. So theoretically, you could get 120% in participation if you came every day and you didn't ask for any extensions to your homework. Now, how do you get an extension? Let's suppose week 3, life was just hectic and you just didn't have enough time to finish your homework. You just send me an email saying, I'd like to get an extension, please. And I will do that. But you won't get the extra point for doing that. If you miss a day because you've been at the dentist, do you see that if you do the homework on time, doesn't it compensate for that missed day? So, because 1 participation point is the same as 1 day attendance. So that's how that's going to be. Well, let's talk about the homework. Well, you already know what it is. Every week you've got certain sections to do. They're all on WebAssign. When you do WebAssign, which I think I'll show you in a few moments. In fact, why don't I show you right now? There. Are we now looking at WebAssign page? Ah, perfect. Okay, so this is kind of what you would see if you looked at WebAssign. And I'll fix that. That's the wrong one. If I click on this one, for instance, here are your questions. This one little video that you can watch tells you what to do. This here is a tutorial, so when you click on that, it gives you steps that you do. This one here is a table. You're going to put your answers in there. Here's another question. You put your answers in here. So, yeah, you do that. And I know that's totally wrong, but if it was right, you would go submit answer. And it'll come back and it will tell me that I'm wrong, if I can find it. And I'll overshoot it. There we are. You see our lower X? But I could try again. And I'm still wrong. But I believe you get 5 shots. So you will, if you're careful, right, be able to get it correct. You know that sometimes you do a question and you're just not sure what's going on. Then you could simply shoot me an email and say, I'm having trouble with question 5. What, here is what I'm doing. What's up? Or you could drop in during office hour and we could share a screen and I could see what you're doing. WebAssign randomizes the questions, at least the data in the questions. So do you see all these red numbers here? That's what I've got. If John went and looked at his question, these numbers would be different. So you can't phone up John and say, John, what's your answer to question 7? He'll say 42. You'll type in 42 and it will be wrong because it was 42 for him because he had his numbers, but it'll be 22 for you because you have different numbers. So you see, you can't really cheat that way. So you got to make sure that you do it, right? And it's good practice. Homework that's its job. You don't really fully understand mathematics, I think, unless you practice doing it, right? Doing questions and getting the answer on your own. That's how you know if you understand something. The class tests are basically going to be, looks just like a homework, but it'll be called class test 1, class test 2, and so on. Has to be done as homework should be by the midnight of Sunday. That's the cutoff day. And then we'll have a midterm, and then we'll have a final. And then you add up all your points and you weight them according to the percentages, and you get a grade, and a 4.0 is 95. And these are the decimal letters for it. Now we have online tutoring. So you can actually, even if you don't go to the college, you can go to the tutoring site on OC's webpage and find out how to do that. A lot of people have study partners, right? You just know somebody and you email each other for help. I've got a lot of resources in Canvas. WebAssign has features as well, right? You can try another example. If you click on it, it'll link you, in some questions at least, it'll link you to the ebook where they talk about that topic and maybe give you an idea how to solve it. General advice. If you get to Calc 1, you already have figured out how to do this because you've been successful in the past. Keep to the schedule. Don't do homework at 8 p.m. on a Sunday night. Because if you get stuck, there's no way in the world I'm going to be able to help you, right? And you might not even have enough time to finish it. I think it's much easier on you, and you'll spend a lot less time doing it, is if you do homework pretty much as soon as you finish the class, because it's fresh in your mind and you get practice at it, and that helps you to remember it. That would be my advice. Get help as soon as you can. If you get stuck, try and organize your time, because I know you've got other classes, but when a midterm or a final's coming up especially, try and make sure that you've allocated at least a reasonable amount of time to be prepared for doing that. and the usual things to do with what is expected of you and what you should be able to do. Any questions? That's kind of the syllabus as far as I want done. Great. I'm glad you didn't ask questions because I want to go on and do math now. So let's do that because that's the fun stuff. Right, so repeat it there. What is calculus 1? It's an interesting question. How did it happen? Give you a little bit of history behind it. In the late 1600s, mathematics as we know it or today was quite different. It was basically based on Greek mathematicians, the Greek math, you know, Aristotle and Pythagoras and all those guys. And there was a problem going around called the tangent line problem. And it was bugging the heck out of everybody because they couldn't solve it. So I want you to imagine you have a function, y equals f of x. And the tangent line problem seems to be a pretty simple problem. Choose a point P on the curve, any point you like. It has a line called a tangent line. That's this red line here. Basically, a tangent line is a line that just touches the curve, right? And no other. Every single point on a curve has a unique tangent line, right? So if I did the tangent line down here, wouldn't it be a line pointing somewhere like that, right? Be totally different from the red one, right? And here would be a different tangent line again. Every single point has a tangent line. And we were interested in finding the slope of the tangent line. It's called the tangent line problem. And no one could figure out how to find the exact value for the tangent line. There are lots of ways of getting an estimate of it. Some very, very good estimates, right? Like the 10 decimal places accuracy. Took you a long time to do it, but they didn't have a way of getting the exact value of that tangent line. Well, let's look at some of the ways in which they tried it. The first one was hopeless. You got a ruler, you draw what you thought was a tangent line, and couldn't you just basically build a little right angle triangle and do rise divided by run? Would you agree that's a pretty primitive way of doing it? Why? Well, here's lots of problems. If I gave you a ruler, or if I gave every single one here a ruler, and I gave you a photocopy of this piece of paper, and I said to you, draw the tangent line, do you think you're all going to draw the same line? No. So Alia's going to be a bit steeper, Carter's going to be a bit shallower. So right off the bat, which one of you two is the right one, right? You can't really tell. You know, you eyeball it, they look the same. Secondly, if for some reason I could do a perfect tangent line, wouldn't I have to measure this distance here, which is the rise, and wouldn't I have to measure this distance here, which is the run? Well, how would I measure them? Well, wouldn't I get a ruler out and measure that distance? But how accurate would it be? Would you agree you could probably only do it to maybe 0.1 of an inch if you were really good? That's not perfect, is it? So they said, we're not doing that, right? We're not going to get a slope of a tangent line doing it that way. So they figured out other ways to do it. This is their second attempt. That's the guy we want the tangent line for, right? That little fella there. So what they did is their second attempt is they said, okay, there's the point P. I'm going to pick another point over here called Q. And I'm going to join P to Q. And I'm going to find the slope of the line joining P to Q. And we call that MPQ. I do not know why they use the letter M for the slope of anything, but MPQ means the slope of the line PQ. So I'm going to make up a reason. Slope is probably a word that starts with the letter M in French, right? And so we end up having to use it, right? That's as good a lie as any other lie, right? So MPQ, slope of a tangent line. So what they did is they find the coordinates of this point, and we find the coordinates of that, and that can be done, right? And can we pretend that this curve is x cubed plus x, just for argument's sake? Right, so you can find the coordinates of P. Let's suppose P was 1, 2, and then you got the coordinates of Q, and that would be 2, and that would be 2, 10. Then couldn't we find the line joining P to Q? Right, we could find that slope. The line from P to Q is called a secant line. And if you want to find the equation of a line joining 2 points together, right? You want to find the slope, I should say, of it. There is a formula for finding the slope. The slope of a line is the rise divided by the run. And isn't the rise the difference in the y coordinates divided by the difference in the x coordinates? Agreed? And since I know the x and y coordinates, I should be able to find the differences, right? The difference in these y coordinates is 10 take away 2, and the difference in these x coordinates is 2 take away 1. And so the answer I got was 8. Now, there is a big problem with that, and it's a really big problem. Would you agree that the line PQ is not really the same slope as that red tangent line? Would you agree it's definitely different? And they knew it was different, right? It was pretty obvious. So they went and said, well, can we fix it? Well, there is a way to fix it. I'm not going to change P because that's the guy I'm interested in, but can't I choose a different guy for Q? So instead of this one, couldn't I pick somebody a lot closer to P? Wouldn't that be a better estimate? So instead of an x coordinate of 1 and 2, how about an x coordinate of 1 and 1.1? So I'll do my little calculation here right now. 1.1 cubed, add 1.1, right? That's the function. And I get the answer that this is 2.431. Are you comfortable about if the x coordinate is 1.1 and the function's that, then this is the y coordinate, right? So let's find this fella. Well, the slope of this secant line is 2.431 take away 2, right? The difference in the y's, the rise, and the difference in 1.1 to 1. And this ends up being 0.431 over 0.1. And this ends up being a slope of 4.31. Would you agree that that's a better estimate of the slope of this tangent line? Because if you pick your Q, say here, won't that be very close to the red line? Did you see? Reasonable assumption. And they liked that idea. They went and said, and I'll just do it once more. Can we do better? Yeah. Why don't we pick 1.01? Would you agree that those two guys are almost on top of each other? So wouldn't the line joining those two be darn close, almost equivalent to the slope of the tangent line, right? And I'll have to do a little calculation here. 1.01 cubed, add a 1.01, and the answer I got this time is 2.040301. And now I can find the slope joining P to Q. And it's going to be the difference in the Y's, right? The I's, difference in the X's to run. And this ends up being 2.040301. Take away 2 all over 1.01, take away 1. And so we got 0.040301 over 0.01. And now we got the answer 4.0301. Now that slope is virtually the same as that tangent line. You agree it's a very good estimate. And then we use a fancy word. We'll make a conjecture. And we're going to make a conjecture for the slope of the tangent line, which we're going to call M tan. What would be your best guess? Think of conjecture as being intelligent guess. What would be your best guess for the exact value of the slope of this tangent line? Any takers? That guy? That guy? Who's this guy?
4.
I would say
Closer to
4.
4.
Yeah. Would that seem reasonable? And that's what they did. They essentially, to find the slope of a tangent line, as long as you know what the function is, right? Can't you take P, because that's the guy you're interested in, and then just choose a Q that is really, 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 really close to P? Now, if you were, I don't know what the word I'm looking for, pernickety, that's a good word. Couldn't I have used 1.00000001 and couldn't have done the calculation and couldn't have done the rise over run? And wouldn't I get, and you're just going to trust me on this, wouldn't I get the answer 4.1800302? And wouldn't that be pretty convincing that 4 was the right answer? And for engineers, that was fine. That's how they used to do it in the olden days when you needed to know a tangent line slope. And sometimes you need to know tangent line slopes because it's a very efficient direction to put a girder or a rafter, right? It's the best angle if you want to meet with two things, right? Whatever the reason is, you got that. But mathematicians are never happy with estimates or guesses, even if engineers are. We're making the conjecture here as 4. That's not the same as saying, I guarantee on my life that the right answer is 4. Because mathematically, at least, isn't it theoretically possible that the real slope of the tangent line was really 4.2 billion zeros and a 7? Theoretically, couldn't that be true? You don't know, because aren't you basing it on numerical calculations? And isn't that only dependent on how close to P you pick your Q, right? But couldn't you always get a little bit closer? Just add an extra 0 and wouldn't that be a little bit closer than the one you just used? Add another 0, there's a little bit. So you've got this infinite possibility that there might be a slight difference from 4. They did not like that. So they tried this trick and it failed miserably. Well, here is P. Why don't we pick Q to be the same place? And if we try and find the slope, which is the difference in the Y over the difference in the X's, uh-oh. Can you see heads exploding. If you make P and Q the same, isn't the slope of the line joining P to Q, if you use the formula difference in y's, right, divided by difference of x's, don't you end up with 0 over 0? Now, some of you might be thinking, oh, 0 over 0 is 1. Please don't think that. It never is 1. 0 over 0 is, the jargon that we use is it's undefined. Now, sometimes undefined is a kind of catch-all for we don't know what you're equal to. It could be that you're not equal to anything particular, but it could be that you're equal to 4, right? And so the whole next, 2 weeks is going to be devoted to figuring out how you can solve questions like this. How can you make P and Q so close together that they're identical, right, for all intents and purposes? Because if you can figure out a way of doing that, and the technique is called limits. So if you can find the limit of this thing, you now have a way of coming up with the exact value for the slope of the tangent line. Oh, by the way, the exact value for this one is 4. But I know that from calculus, not from estimates. So that is going to be our goal. We are going to be looking at how to calculate the slope of a tangent line. So let's return back to here. So there's a point P, this is a point Q. How do you find the slope of the line joining P to Q? We call it this guy. It's rise over run. You can call it difference in y's over difference of x's. And let's put some meat on this. Let's call this guy xp, yp. And let's call this guy xq, yq. Then won't the difference in the y coordinates be yq take away yp? And the difference in the x coordinates is called xq take away xp. So here is a formula for calculating the slope of a line joining P to Q, the secant line. Here is another one. Has anybody seen this version of rise over run? Right. Now, some of you might have used this version. Y2 take away Y1 over X2 take away X1. Have you seen that version of rise over run? Right. Now, do you know that this, and this are all the same? Agreed? And they're just different ways of telling it or writing it down. Now, you can, if you're doing your day-to-day working and you like that notation, do it. If you like this notation, do it. If you like that notation, do it. Of course, if you're going to use that notation, won't we have to call this guy X1, Y1, and won't you call this guy X2, Y2? That's the only difference, right? You have to know what to call them. So I don't want you caught up on notation, right? I have no particular preference. I'm slightly lazy, so I probably would like to use that one because it means I write less than that one or that one, right? Do any of you have, oh God, please, will you only use that one? Because that's the one I'm used to. Has anybody got any, is that the one you want then? No? Any preference? I'm looking at faces. You're all fine no matter what I use. Should I just mix and match them then to make your life harder? Okay, I may do that. So basically, let's check off my little list. I've went over the syllabus, which is nice. We've talked about, just finished doing it, how to find the slope of a tangent line. Let's move on to do a secant line. Or are we going to be able to do a secant line? I'm just looking at the time here. Yeah, okay, I can do it once. We're going to be looking at how to find basically the slope of an estimate for the slope of a tangent line at some point P. So let's have T and let's have volume. And at the 5-second mark, 10-second mark, 15-second mark, 20, I need one more. And at the 25-second mark, the volume in a tank was 100, and then it went down to 80, then it went down to 50, then it went down to 20, and then it finished at 5, right? So you imagine you've got a big tank and you're draining gasoline off it, right? And at the 5-second mark, there was 100 gallon left, right? At the 25-second mark, right, there was 5 gallon left. And we are interested in this guy here. He's going to be P. So the coordinates of P are at the 15-second mark, there are 50 gallons. And I'm trying to find an estimate for the slope of the tangent line at that point. In this case, what we're calculating when we find this slope is the rate at which the water is, or the gasoline is being removed from the tank, right? So the answer is going to be something like minus 15 gallons a minute, right? That kind of thing. So I've got my P. I'm now going to choose a Q. And I'm going to pick this guy over here as my Q. So his coordinates are 2020. And now I'm going to find the slope joining P to Q. So changing Y, changing X's, actually. If I'm being really correct, isn't it the change in volume over the change in time? Because that's basically my X and my Y's, right? And the difference in the volumes is 20 take away 50 divided by 20 take away 15. And that becomes negative 30 over 5. And so that's negative 6. Okay, that's my first one. And now I'm going to change, and I'm going to use that guy to be Q. So I now have P is 1550. I'm going to use this as my Q. So that's 10, 80. The slope joining P to Q is going to be the difference in the volume divided by the difference in time. 80 take away 50. 10 take away 15. This number here is 30. This number here is, oh, that was a fluke, but kind of nice. Now my job is to estimate what the slope of the tangent line at the 15-minute mark is. And I chose those two guys to estimate it. And then I later on decided to choose those two guys, right, to estimate. And both answers in this case are negative 6. So my estimate would be negative 6. So at the 15-minute mark, gasoline is coming out of this tank at the rate of 6 gallons a minute, right? Negative 6, right? 6 gallons a minute. Just flukes of numbers. Can we pretend that this guy was negative 10 and that this guy was negative 12, just for argument's sake, right? A different table, different set. What would I choose then in this second scenario for the slope of the tangent line at 15? What would be a reasonable way of combining these two?
It could be -11.
Just take their average. Bit hard to talk about adding two negative numbers together because it looks weird. But in your head, would you agree? -11 is as good an estimate as you're going to get. Would you agree that if the only thing you have is a table of values, that is going to be as good as your answer is going to be, right? I can't do a 15.0001, right? Because I don't have any formulas to work with. I can only work with my numbers. So if you're going to get estimates of tangent lines from tables, isn't the best way to, if you're interested in that point, is to pick one guy next to it on this side and one guy next to it on the other side, find out what those two answers are and average them out. If they're both the same number, say, great, -6. If they're different, won't you average, right? If one's -10, the other's -12, -11 seems a reasonable compromise. And that's the engineering solution to inexact information. Would you agree that this is not perfect information? It's little snapshots. You really don't know much more than just that. But it's something, right? It's a way of coming up with how much water is gasoline is leaving this tank at any given minute. Can you imagine in real life, oil tanker, hole in the side, oil spewing out kind of situation? You don't have a formula that tells you exactly what's happening at any given point in time. Don't you just measure it and then 5 minutes later you're, oh God, look how much just came out, and then how much more just came out. You could create a little table, couldn't you, reasonably quickly and say, okay, what's happening here? I would expect it to be pretty crude, right? I wouldn't want to bet my life on that being the exact answer. It's based on inaccurate or relative data. Okay, guys, one last thing before you go. In the attendance, or how I take attendance, if you've had me before, you'll know how this is going to work, but for the rest of you, it's a little bit new. Go to the chat and type in your last name. So Samantha, you're going to put in Smith. And that's it. Bye-bye.